Hey everyone, thanks for being here today. I know it's super early and everyone probably had a bit of a night last night, so I appreciate you being here. Today we're going to be learning about Jetpack Compose in the context of Android TV. So for those who haven't met me before, my name's Joe. I'm an Android engineer at a company called Buffer. I also run Droid Academy, where we publish books and run training courses for Jetpack Compose. My Twitter handle's there if you want to follow me on Twitter, and Mastodon, and all the new stuff that's coming out. So just to set some expectations for this talk and what we're going to be learning about today, mainly we're going to be looking at Android TV, learning some fundamental concepts of user experience for Android TV, and then also looking at some new composables that are available that we can use to build TV apps. This isn't going to be a deep dive into the internals of Compose or how these things work under the hood, but I want you to be able to go away and know what's available for building apps with Android TV, and then be able to go and use them yourself if you want to. So when it comes to TVs, I'm sure most people in here own at least one TV in their household. I know some people have 3 or 4 TVs. So it's a huge ecosystem that we can tap into for our products and the things we're building. There's actually around 150 million monthly active devices that are running the Android TV system. This includes actual TV devices and also Chromecast devices. So for the apps that we're building for our mobile phones, there's actually a lot of potential here to tap into and connect users on another form factor, whether it's media apps, food delivery apps, music apps, or anything. There's a huge potential here. So when it comes to Android TV, before we start looking into things to do with Compose, I want to touch on some of the UX concepts around TV itself, because this differs greatly from mobile, and it's a little bit of a shift to how we build things for current experiences. So the first thing I want to look at is navigation. So when we have our handheld devices and our phones, we're used to moving things around with our fingers, tapping on buttons, and all of that stuff. That's very different when it comes to TV, because I've never used a TV that is touchscreen, and instead we use these hardware controllers to move around the screen and the options that are available. So this is one of the biggest differences when compared with mobile. And this seems very obvious, but it changes things quite a bit. So maybe you have an Android TV device, or you have some other kind of TV controller, but there's often a directional pad which allows the user to move in 4 different directions, a button that is used to select any highlighted option, and then there'll be several other buttons on that controller as well that lets the user go back, return to the home screen, and then also often talk to the controller so you don't have to use that really annoying keyboard on screen to type things in that takes ages. And I'm sure we all got frustrated by that at some point. The most annoying thing is when you have one of those really tricky passwords on one password, and you have to type that into a TV. That is not fun. So we talked about the D-pad. So the thing with Android TV is when you're moving around components on screen using the D-pad, we move in 4 different directions. So we're essentially changing the focus on items as we move through them. So if I want to browse shows, I'll browse in a horizontal or vertical format using the D-pad to move through them. Now, the nice thing is that the Android TV system will actually handle a lot of this stuff for you. You don't need to be recreating complex navigational structures. So if we have like a layered UI with different sections, if the user is using the directional pad, this will automatically move through them as the user navigates through them. So the important thing here is that we don't need to recreate these navigational experiences. And in fact, there's a lot of experiences that the user is used to on the TV, so we want to lean into those and just use the system and let the system do the work for us. Because the thing with this is, you finish work, maybe you sit down and you just want to choose something on the TV and find something to watch. You don't want a complex navigational structure. So let the system do the work for you on that one. The next concept we have is focus, and this is something that we are aware of on mobile, but it's something that we don't need to rely on as much. So for example, let's say we're on a mobile device and we have a collection of options that we can browse through, scroll through, and then select. Most of the time we'll see something like this, and we'll tap on the item, and the item will come into focus briefly and maybe be enlarged or highlighted, but that will only often be for the time that it is being touched, unless we're using accessibility services or some other kind of input. The difference is with TV that this doesn't work because when we're looking at the screen, we need to know what item is in focus, so we know how to get where we want to go and what item is currently going to be selected. So for this, often on TV, we need to add emphasis to the items that is currently focused. So the cool thing about the new Compose APIs is that a lot of this work's actually done for us, and a lot of the composables have properties that allow us to increase the size, add glow, add borders, so it's all out of the box, so we don't need to do that manually. So the cool thing here is that another thing about this with TV is that often when you're watching TV, you might get distracted, like the door might go, your dog might come in, and you'll look away from the TV. And you can do this now. If you look away from the screen and you look back, looking at this, you automatically know what item is currently selected, and you can continue your journey from there, whereas we don't have that same issue on mobile because focus isn't as much of a thing. And this is true for all components that we show in the UI of a TV app. If there's, at any given time, there should always be an item that is on focus on screen, unless the user is immersed in some kind of content. And as we move through the items on the screen, the focus should change, and it should be clear where you are at in that user journey. So when it comes to focus, focus should always represent an action. If something can't be interacted with or can't be clicked, it should not be focusable. So just like in mobile apps where we add content descriptions for things for accessibility purposes, and we often don't add content descriptions if something doesn't portray meaning, the same thing is true for focus. If it can't be interacted with, just leave it. And finally, all experiences on TV should be immersive. So if we're viewing media, it should be full screen and interrupted. This is an immersive experience because the media is the primary focus. And often we might see things change in the UI. Maybe, if you've used Netflix, you hit the up button on your controller and this UI pops up. This happens, but then if you don't interact with anything, it moves away. We're taking that work off the user, and they can continue viewing their media once that disappears, so you can easily return to that original state. And we can also lean into things on Android TV like picture-in-picture mode. You've likely seen this. If the user moves away from your app, maybe they want to order some food, check something else on the TV, they can continue watching your program and easily return to it with very little effort. This keeps them engaged in your application, and they can go on back to it whenever they desire. So even when browsing content, we can get creative with this immersive experience. So this isn't something that comes out of the box on Android TV, but we have the ability to hook into the focus for all the items that we're showing, so we can show previews and keep the user engaged and let them know, if they want to watch this show. And when we talk about immersive experiences, we talk a lot about media, visual content, and that's what we really should be leaning into when we're building TV apps. It's okay to use text. We need to know what a show's called. We need some kind of description, but text should only complement the visual media that's there. We shouldn't really, if we're looking at a TV, we don't want to spend our time reading stuff. We want to be watching stuff. So it's okay to use text, but don't rely on it for meaning. So now we've got some of the UX things out of the way. Let's move on to Compose. So when building TV apps with Compose, the great thing is that it's actually a super familiar experience if you've already been using Compose. We're using exactly a lot of the same libraries, a lot of the same APIs. The only addition is there's these 2 extra packages that are currently in alpha that basically add a collection of composables that are specific for TV apps. There are some nuances which we'll come on to a bit. There are some specific material components that are built for Android TV, such as buttons, switches, surfaces. And when you're using Android TV, you need to make sure you're using those ones, but maybe that will be made simpler down the line. So you can use these alongside existing Compose APIs. So for the purpose of this talk, we have this really simple sample app that uses a bunch of the components that are found in these Compose libraries. They're very little code to use, but we're going to be using this sample app to run through each of these components and then learn how we can use them ourselves. So the first thing we're going to move on to is lazy layouts. So if you're using Compose already, I'm sure you've probably used some kind of lazy layout. So lazy rows, lazy columns, maybe lazy grids. Most commonly used thing on Android TV probably, and they're basically used to load continuous content and allow the user to browse through things on the screen. So when it comes to Android TV, the first TV-specific thing that we have is actually a TV lazy row. So instead of using the lazy row on Android TV, you want to be using the TV lazy row. And this allows you to lazy load content in a horizontal format. And the great thing about the TV lazy row is that it has automatic focus and navigation management when compared with the standard lazy row. So in the example, this is what we see when we're using the TV lazy row. You might be able to notice some differences with the focus management and also how the offset is managed. We'll come on to that in a bit. But essentially, the user doesn't need to scroll right over the end of the list to continue seeing the content that is coming after it. And I didn't realize this at first, but the actual lazy row doesn't do this, only the TV-specific one. The composable itself is actually very simple, and if you're familiar with the lazy row API, you're probably noticing a lot of similarity here. There's only one key difference here, which is the pivot offset argument, which allows you to offset how much of the next content should be visible on screen. And other than that, there's just some exclusions that they've done to make the API simpler. So there's some things from the lazy row which you can't do in this one. And when it comes to composing this, just like we would do the lazy row, very little code there. We can add the padding, the arrangement, and we compose our items using the exact same lazy row scope that we would do for the lazy row itself. So we're using this to display horizontal scrolling content. Primarily, it's used to display content in feeds. So if we're on some kind of home screen, we allow the user to scroll through content and view what's available to watch. In most cases, you're going to be probably using this over the column variants just because it's, again, an expected user behavior and it's what they're used to doing when browsing through content. But there's probably going to be some cases where you can use the columns. So similar to the TV lazy row, we also have the TV lazy column, which I'm sure everyone is aware what that does because it's just the opposite. It shows content in a vertical format. So in the sample app that I built, we have a simple settings screen that allows us to show content. And again, we can see how as we scroll through this, we have the automatic focus management, and then we also have the preview of the next items before we reach the end of the list. And that's a really important thing when it comes to TV because it keeps the user aware of what's coming. And very similarly, we have the same kind of the same API for the TV lazy column. And we can compose it in the same way using the items function to compose children inside of it. So we've seen these very two simple composables so far. And one thing, well, when I started playing with Android TV on Compose, I was just using the lazy column and lazy row. I didn't even know that these existed. And the interesting thing is, under the hood, they're actually pretty much the same. They both use the same lazy layout from the Compose Foundation package, but each has their own lazy list implementation under the hood to cater things to each of their own platforms. So as we can see, these composables are very similar. I pointed out how we have the main difference of the pivot offsets. That allows us to offset content so that the user can see what's coming next. And then there's also some exclusions on the lazy the mobile-specific side of things, such as a fling behavior, because you can't scroll with your fingers on Android TV, so the platform doesn't allow you to set that, which makes sense because then we're enforcing developers to follow certain patterns. So the main difference, as I mentioned, was the way things scroll, and I just wanted to highlight this just so we can see exactly how it behaves. So this first video up on screen is the lazy row, the standard lazy row on Android TV. And we can see here how I go to the end and I have to scroll to the next item using the D-pad to see what's coming next. And this doesn't give me a preview of what's coming. It's not as immersive, especially when compared to the TV lazy row, where as we scroll, we can always see the next two items in the list. I can always see what's coming, and I get a kind of a preview of what's coming next, because the stuff I've scrolled past, I don't need to know about because I've already seen it. So this is incredibly helpful. So when it comes to these, we want to use the TV layouts. We ensure that we have these specific behaviors applied automatically. We don't need to worry about customizing things ourselves. We have a familiar API. We don't need to learn new APIs. We don't need to educate our developers on these new things. It's just essentially switching out the name of the composable. And we get to enforce these composable properties and scopes that are specific for TVs, which is obviously a great thing for us to be doing if we're building TV apps. Now, alongside these columns and rows, we also have grids, which come with the TV. I can't remember if these are in the standard Compose APIs. I haven't used them at least, but I remember some time ago they weren't. Maybe they are now. But anyway, we have TV-specific equivalents, which very similar to the rows and columns. They do exactly the same thing, except they allow us to display content in grids. If you've used search functionalities on Netflix and Disney+, you've probably seen grid layouts being used, and this is exactly how these behave. So we can display things in columns and rows and composing items using very similar scopes as we saw in the columns and rows previously, which gives us something like this, a very nice fluid, smoothly scrolling structure, And we can see how, just like the rows and columns, things are automatically scrolled, so we can always see what is coming next on the screens. Now, the cool thing is the grid is we have the ability to control the number of columns or rows, if you're using the other alternative, based on a certain setting. So, for example, we can fix the columns to a certain amount of a certain number, which would give us something like this. So here, no matter the size of the screen, we're always going to see 6 columns displayed. Alternatively, we can use this adaptive flag, which allows us to define a minimum size that the column should be. And if there's any remaining space, this will be distributed evenly between each of the columns, which will give us something like this. And the cool thing about this is that regardless of the screen size, we can always ensure that our content is going to be adapted for each of the screens. And in composing this, on the alternative side of things, we also have the horizontal grid, which we won't go too much into this. It does pretty much the same as the vertical grid, except it gives us the ability to scroll content the other way. So if you're looking for a horizontal fashion of organizing things, you can use this grid instead. So when it comes to grids, we've seen the rows and columns, but grids are more adapted to displaying large amounts of content, especially if it's content that is grouped in some specific way, like if we're grouping films by action or drama, then it's a great way of grouping that content because it saves the user scrolling through a long horizontal list. They can see everything on screen. We can use tabs to offer content filtering. We'll come on to that a bit, but there's ways you can filter the content so that the user is displayed not so much content. And then making use of the adaptive cell sizing is great because it allows us to scale things based on the size of the screen that is available. So now we've looked at laying out content and using lazy layouts. We're going to come on to some TV-specific things that you won't find in the standard Compose APIs. So the first one of these is known as a carousel. And a carousel is used for highlighting content on the screen that you want the users to know about. Maybe they're new TV shows, maybe it's a new album that's being released, or some of the top games from this week. This carousel allows us to highlight content and gives our user easy access to it. And the nice thing about this in the Compose TV APIs is it's very little code to get up and running with this. This is what the carousel composable looks like. We can see a collection of arguments that are optional, but there's very little that we need to provide to get this composed on our screen. So the first thing is that we need to let the carousel know how many items we're showing in the composable. This will depict how many slides are being displayed and then how many dots should be shown in the indicator. We can also control things around like the transitions, the timings, and how long things should be shown for, but this is all optional. If you don't provide these, then the defaults will be applied. We can control the indicator that's used. The out-of-the-box one looks pretty nice, but if you want to customize this based on your theme for application, you can override this and provide your own indicators for the slides. And then finally, we have the content, which is a required argument. And this is essentially the composable that defines the content for each item in your carousel. So when composing this, there's very little code that's needed. Essentially, in the example, I have a list of featured movies, which is just a simple colon data class. The item count is defined by the size of this list. And then essentially, when it comes to the content, the function will receive the index of the currently selected item, and then you can compose that item based on the currently selected item. So very little code there that's required to do that. So when it comes to using the carousel, we're going to use it to highlight featured content in our app, content that we want the users to know about. We should always provide a way to access that content. So you may have seen on the video that along with the content, there was a button for the user to watch the selected show. If the user hits the select button when that slide is selected, the show will start playing. If we don't do that, the carousel is a bit pointless because we're showing the user something, but we're not giving them a way to access it. And remember, we want the user to be able to access the content on TV in very few clicks. So doing that allows them to do that. And it's not a replacement for content feeds. Using the lazy layouts to load content onto our app is the main way we're going to be representing content to the user. The carousel is just for highlighting that content. Now, alongside these carousels, we also have what are known as immersive lists. So immersive lists are a pretty cool composable that allow us to, again, highlight content, but it's more of like a full screen experience. So here, we can see that I have my TV lazy row, but what the immersive list does, it allows me to take the background of the current item, show it on the full screen, and then also show some additional content. And this is a really cool way of allowing the user to browse content while also giving them more information on that selected item. So again, we see the composable. Very little here that we need to provide to be able to use this. We have the background option that allows us to define the background that's going to be used for the selected item, along with the list, which is the content that's going to be displayed for each item. So when composing this, we need to start with the immersive list. Composing the immersive list itself is very simple. And the background itself, I've omitted the code here, but all I've done for this was just use an async image from the composable, the core compose library, along with some simple text composables to display that information on screen. And then for the actual content itself, all we need to do is use the TV lazy row, loop for items, and then compose a card for each of those. Now, the important thing to note here is that we have to use, currently, this might change, but when we're using the immersive list composable, we have to use this modifier on the item of the list that we're providing for the immersive list. And the reason for this is that it informs the parent immersive list what item is currently in focus, and this is so that the current background and information can be displayed to the user. So if you're using the immersive list, you have to show this. And I didn't realize this at first, and it was very frustrating until I checked the documentation. So using the immersive list, we need it gives immersive focus to the currently selected item. While we can use the TV lazy row to show content to the user, this allows us to keep the user immersed in the content that we're showing. We can show more information for a content, like descriptions, the length of the film, and so on. And it's greater efficiency for the user. Usually, we have to click into content to see a detailed screen, but this shows it on the screen. So we're removing a whole click from the user, or even a couple of clicks, so they don't need to go back. They can see it on screen there and then. So now I want to move on to the navigation and some of the new navigational APIs that are available to the user. So this isn't about navigation graphs. If you're using the Compose navigation component, you can still use that. It's exactly the same. Nothing has changed there, so we're not going to talk about that. But we are going to talk about some of the new composables that are available. So the first one is a navigation drawer. And this wasn't previously available in the old view-based lean-back library. So when I saw this, I was like, what is this? Navigation drawer on TV? But it's actually a really cool and handy component because a lot of TV apps you use have these, so it makes sense for it to be provided. So the first one that is available is the navigation drawer. So this allows you to define the drawer content, and then also the child content of the drawer. So what this does is when we provide the drawer content, this is going to be the composable that makes up your menu. And then the actual content argument is the content of your screen. So in this case, the content of my screen is going to be the navigation graph, which allows me to load the currently selected item. So we can see here for the navigation drawer, this is the standard one. I can move into the navigation drawer, I can navigate through the items, and then return straight back to the screen. And then when I click one of these, I can trigger the change in my navigation graph, and then the navigation graph that's in the content of my drawer will be updated to change the content that's displayed to the user. And it's cool because with this standard navigation drawer, we can hide the navigation drawer, it will collapse it, and the user has more space to browse the content of our application. Alongside the navigation drawer, we also have what's known as a modal navigation drawer. And this is a slightly different one, exactly the same arguments, except we have the ability, it basically shows a scrim. And one of the extra arguments here is we can control the color of the scrim that's going to be shown. So if you don't provide this, there'll be a default color applied, which if it goes to the next slide, then it will be something like this. So the default color is just kind of an overlay over the top. Would probably make more sense to darken this so it's more visible, but this essentially allows you to show a menu over the top of the content, and the size of the content doesn't collapse. So if you're showing more complex menus or more content here, then this might make more sense, but there's two options available here currently for you to pick from to do that. Alongside navigation drawer, in some of the videos we saw the use of these tabs, and this is also a new composable that is available specifically for TVs. So again, very simple composable structures. We have two composables here. We have the tab row, which is the parent container for the tab, and we also have a tab which represents each of the children. And when it comes to composing these, we can simply do like so. We just need to keep a reference to the selected item, as in remembering it via state, and then using this to compose the tabs and configuring which one is currently selected. So essentially, we just need to use the onFocus callback in each of the tabs to update the currently selected item, and then that will be reflected when the tabs are changed. So we can see that like so. And all I'm doing here is essentially using the currently selected tab to filter the content of the grid. And I spoke about this earlier, because grids can contain a lot of content, and that's what they're made for. But if you can simplify that for the user, then it's a great way to do that. So what we do here is we just use the selected tab to filter the films by category. So one thing I mentioned earlier was material components, and this is another thing I wasn't aware of until I checked the release notes. But there are actually a bunch of material components that are in the Compose TV packages that have exactly the same names as ones that you'll find in the standard Compose material packages. And it's important to be aware of when you're importing these, which one you're using, because there are a lot of big differences, and we'll see some of these in the examples. So one of the nice things, first of all, is that the Compose TV material package comes with a bunch of predefined composables for different cards. You haven't got to make these cards yourself. You just provide it the content you want to show, and it will lay it out for you, which is really handy because it just makes it really quick to put the cards together. So there's 4 types of cards available. And we have the wide card layout, which is essentially a card with an image content. You can also provide a title if you want to. We can see very simple structure there to the composables. We also have this second one, which is the standard card layout. This is very similar, except it allows you to display a title underneath it, as long as there's also an opportunity to show a subtitle if you want to. We also have a classic card, which is contains that bit at the bottom, which we've often seen in a lot of apps, a lot of TV apps, and especially the previous lean back library for older TV apps. I don't like this one as much because it just doesn't look as nice, but it is there if you want to use it, and I'm sure it has its use cases. And then we also have this 4th card layout, which allows you to provide, again, content, a title, images, and so on. And these are just really nice because when it comes to creating cards, there's often a lot of boilerplate and a lot of configuration we need to do and laying things out on columns and rows. But the nice thing of these is that each section of the card has its own argument, and you can provide it, and the cards are laid out and configured for you. And again, the cards have different, when compared with the standard Compose cards, they have their own focus, like their own scaling and glowing. So using these TV ones will automatically ensure that they're going to look good on TV apps. And second up, we have Surface. So Surface is something we already have in the Compose APIs, but again, there's Compose-specific ones. And I want to show you the difference between some of these. So this is the standard Compose surface used on TV. And it has a bit of a highlight, but it's not immediately obvious what item is in focus. Again, if you looked away from the screen and one of these was highlighted, you wouldn't immediately know. It would take a few seconds for you to realize which one is selected because it's just a slightly different color. We have a surface composable that comes in the TV material package, and one of the differences here is all these properties that don't exist in the standard surface from the Compose material package. And these basically control the scale, the border, the glow, and the shape of the surface based on its focus state. So this means that when we're using the TV surface, it's a lot more obvious which item is currently selected. We can see its scale, we can see it change color slightly, or a lot more obvious than the other surface anyway. So if you're building your own composables and you're building things that use surfaces, using the TV surface allows for a better experience for your user. And the same thing, these changes apply to a lot of the TV-specific composables. For example, the switch is another one. If we look at the standard switch from the Compose material package, when that switch is off, it's not actually immediately obvious that that's a switch. When it comes to the TV switch, for example, again, we have a very similar Compose structure, but under the hood, there's different styling, different focus states, and we can see here that the actual switch is a lot more obvious as a switch. Its theming is a lot more apparent, and it fits in more with the styling of the TV components. And the same, we're not going to run through them all, but the same applies for the button, the checkbox, radio button, and there's also a thing called a wide button, which is the image on the bottom of the screen. All of these things, there's more as well, but these are all TV-specific composables that have their own focus management, styling, scaling. So if you are using material components in your apps, or you're extending from them, be sure to use these ones so that you can ensure that the user is able to has a better experience on TV. They can tell what's in focus. They can navigate between things more easily. So finally, I want to look at reusing composables, because when I spotted that there were TV-specific composables, and then we have our standard composables, one of my thoughts was this is going to be a nightmare for sharing stuff, because you can no longer share these lazy columns, and it's going to be more difficult to share the content of them. So currently, we might have something like this. We have a mobile app, we might have a component library, and then that contains our material card. The only thing that now is that we're now going to have two projects. We have two types of card. We have a material TV card, whatever one we're using, and then we're going to have the actual material card itself. And what we can do here is, while we can't share those cards because we don't want to have TV cards in a mobile app, and vice versa, we can share some stuff. And what we're going to want to start to do or see is start to spit out things. So, for example, from our mobile app, what we can do is we can share the content of those cards, and while we can't share the parents, we can share the content that makes up them. So, for example, we can start splitting out the body of those components into their own composables, and then start sharing those things across our projects. Because that's the cool thing with Compose. I'm sure a lot of us are doing this already. There's really easy to reuse stuff. So if we start splitting stuff out from their parents, we can then use the child content of the composables inside of their parents. So for example, something like this, we have our TV movie card, we have our movie card, and then we have the shared content that is placed inside of the body of those. But yeah, if people are already doing this, I'd love to hear more about it. This isn't something that I've been doing in production code, so if anyone is sharing code across their TV apps and their mobile apps, I'd love to hear more about that use case. But yeah, that's it from me. I hope this was a great introduction to the Compose TV APIs. Thank you again for being here. If you want to chat more about TV, I'd love to hang out afterwards. Come find me. I also have a book which I have a website for. If you want to check it out, if you want to learn more about Jetpack Compose, I have a special code on at the moment for 25% off. So please check it out if you want to learn more about building apps for Jetpack Compose. But that's all from me. Thank you for coming. I've got time for questions, so if you want to ask one now, you can. Or if you'd prefer to find me afterwards, please come find me and we can chat some more about Compose, Android, or whatever. But yeah, thank you.